My name is Alton Henley, and this is Intro to Digital Forensics. The first question one might ask is what digital forensics is. According to Wikipedia, digital forensics is a branch of forensic science encompassing the recovery and investigation of material found in digital devices, often concerning computer crime. Simply put, digital forensics is the science of solving computer crimes using the data that's left behind. It is playing Sherlock Holmes with computers. Analysts have to take the data available to them and try to piece together what happened from that data. It can be challenging to do so, but by taking the clues and stitching them together with what is known, analysts get to the point that they can understand how things happened, why they happened, and possibly how they can prevent it happening again. So what happens when a suspected hack occurs? First, the client will share their concerns with an analyst. Moreover, they will tell them, all of our computers started acting weird at the same time. Alternatively, some people got weird emails. Also, all of a sudden our website doesn't work the way it used to. And then they will share the files that they have that they think will help. Sometimes an analyst will request certain things and they will provide what they can get their hands on. However, frequently they do not know how the files are put together. There are things called log files that almost all servers have, where they keep track of what happens on that device. However, these log files are formatted in a variety of different ways. It is not always clear what an analyst should be looking at or how they should be looking at it. An analyst needs to understand that clients often do not know how the files fit together, and they will have to figure it out themselves. Nevertheless, that is where the detective work comes in. So what type of data files might an analyst get? People. So if a client is a company, they should have in some way a list of their people. Further, when I say a list of their people, it could be a list of their employers, a list of their clients, or a list of the users of their system. In some ways, a list of the different identities that an analyst needs to be aware of when looking at the interactions of a customer's systems. They might also have a list of their computers. Now, those computers could be their servers, their routers, their desktops, their laptops, the machines used by their students, by their clients, by their vendors, by their staff. All of that is information that they might have. Thus, it is information that an analyst should be expecting. Emails. When an analyst gets email data, it may be presented in a variety of different ways. It is not going to look the way that it normally looks when in Outlook. They're going to have a log, a record of all the emails that come into the system, and possibly even that went out of the system. In addition to that, they will have the information in the body of the email. So they're not only going to log the fact that an employee sent an email to their boss, but they should also have the subject of the email, the time and date that the email was sent, any attachments that were included in the email, and the text of the email. Internet traffic. Another thing that they should have, or they might have, is records of their internet traffic. Some people are unaware, and it's unfortunate given the amount of browsing that people will do at work without thinking about it. However, generally, most businesses have access to logs of all of their internet traffic. Now, they might not actually be examining those logs, but either the routers, the servers, or even the desktops can be configured to record all of the internet traffic going out, which means the user is requesting websites, requesting downloads, or other requests from the outside world. Furthermore, they should be recording all of the internet traffic coming in, which would be the people coming into the company website. There should be records or logs for all of that. Sometimes that log is one big file that includes all of the incoming and outgoing traffic. Sometimes they are separate logs, one for incoming, one for outgoing. And sometimes the amount of internet traffic is so great that it is not saved in just one file. There will be individual files for this month, last month, and the month before that, in order to make the files small enough so that they can be easily examined. Logins. The fifth thing that analysts might need to examine is logins. So just the fact that someone has a computer and there was traffic coming from their computer does not mean that they were responsible. It might be their boss using their computer, or IT logged into their machine while trying to fix something. Almost all corporate systems will keep track of who logged in at what time and on what machine. So just because Roger's machine was the machine that opened up the illicit website that caused all of our machines to shut down does not mean that Roger is responsible, especially if it turns out that Max was actually the person that was logged into his machine at that time. File changes. And finally, file changes. What will happen is on many systems, they will keep track of every time a file is modified. The files have a modification date as well as a creation date. So analysts need to look at when the file changes occur. Moreover, if the people that were supposed to have access to the machines were not on the machines at that time, and the login log backs that up, then it's clear that something else happened. Let's dig a little deeper. Once we have a sense of the different data files, we need to take a deeper look at the people. So you need to know certain data about your users. There's probably an ID, whether it's a student ID, a faculty ID, or an employee ID. Some companies will use social security numbers, though they shouldn't. And there's almost always some ID number associated with people. The reason you need it is that in the people file, they may refer to him as Sam Jones. However, in other files, let us say the file where they record who's assigned a computer, they may not use the person's name at all. They use the person's ID to identify that this person was assigned a computer. What other fields are there? Well, we also will need to know their name. In the people file, whatever it is, there should be a record of an email address. So if there's an email address you're assigned by the company, then there should be a record of the email address that goes with the name and the ID, because there's always possible that there are two Sam Joneses. One of them might be Sam Jones1 at hospitality.com, and the other one is Sam Jones2 at hospitality.com. But it all depends, and we need to keep a record of it. But it all depends, so we have to keep a record of it. Now, this people data can be in a log file, and it might be one big file, or it might be in multiple files. Maybe there's different files for faculty and staff and students if we're talking about a school, for instance. Analysts will also need information about the computers. One of them is, in almost any corporate setting, the computer has an identifier. Maybe it's the serial number that comes built into the computer. It might also be what's called an asset tag number. An asset tag is an ID number that the company assigned to the computer to identify that computer uniquely. So you need to know what identifiers they're using for the computers. Moreover, sometimes when you look in the people file, you'll see a field that shows a serial number or an asset tag number. Generally, that is the ID of the machine that's been assigned to that user. Now, IP address is something that most of us are familiar with, and it is the unique address used for computers to route their traffic on the internet. Now, while IP addresses are unique, so there cannot be two machines with the same IP address that are working on the same network, it doesn't mean that the computer that I'm using now can't have a different IP address today than it had yesterday. IP addresses can change. Moreover, sometimes they have the same IP address for a particular machine for the entire time. The IP addresses in that case are what is known as statically assigned. So with these statically assigned IP addresses, the fact that this machine is 192.168.1.5 is going to be the same today as it was 2 months ago. However, some machines are using something called DHCP. And DHCP is a protocol that allows us to assign a random IP address in our range of IP addresses every time a machine gets on the network. So you might have the same address yesterday as you have today, but it's more likely that you'll have a different one. This means that there's going to be a separate log of the fact that this particular machine was assigned an IP address at 8 a.m. this morning, and it will keep that IP address until midnight tonight, for instance. So if that is the case, then we need a way of uniquely identifying this machine in that DHCP log. And MAC addresses are the true unique identifier of the network card that is in your laptop, your desktop, or even your cell phone. MAC addresses are totally unique. It is technically possible for someone to change the MAC address, but generally speaking, any computer that has been bought from a store is going to have a MAC address on it, and it will be the same MAC address that it will have until it is destroyed or discarded. The MAC address is the true unique identifier. So if you're looking at a system where they're using DHCP and they have a different IP addresses on different days, then you're going to have to use the MAC addresses to figure out which IP address a particular machine had on a particular day, and then figure out what that machine did on that day. And finally, we have user agent. User agent is kind of a combination of the type and version number of the operating system that the computer is using, along in type and version number of the browser that the machine is using. User agents do not really totally uniquely identify a computer, but it is something that you can use when you don't have anything else. Emails. We're all familiar with emails, and analysts will need to know certain information about the emails. It would help if they had columns or fields that deal with the time the email was sent or received, the sender, replied to, and the recipient of the email. Now, sender and reply to are not necessarily the same, so it's possible, for instance, for an administrative assistant to send an email on behalf of their boss, and of course, the body and sometimes the result of the email. Internet traffic. There are certain things you need to know about your internet traffic. The date and time are key. You will see dates and timestamps on internet traffic log files all the time. Also, the IP address, and it's possible that you will have the IP address of both the requester and the server, although sometimes you'll only have the IP address of one of those, either the machine it was originating from or the machine it was going to. There will also be a request verb, so you will want to look up web request verbs to get an idea of the difference between get, put, and post. That is outside the scope of this training. And the domain that it's being sent to, the request was being made from, and the URL, and sometimes this will be broken into different fields. In others, it would just show the entire thing all as one field. So sometimes it'll be google.com, and then in a different field, it'll show the search parameters, and in others, it'll be google.com/search question mark search equals whatever the search parameters are. However, whichever one it is, you need to understand it when you see it. The user agent, often in the internet traffic logs, will show the user agent of the browser that was used to make the request, or whatever the user was, whether it was a bot or a computer, and you will need to know that and the direction. Now, sometimes the direction is in the name of the file. It will be called the incoming or inbound or internet traffic log, but sometimes it'll just be called traffic log. And inside the file, it will combine both the incoming and the outgoing traffic, and you will have to elicit from that data which direction the traffic was traveling in. Logins. So when people log into your system, there's certain information you're going to need to know. The date and time that they logged in, the username that they used, and the action, whether it was logging in or logging out. Examining our data. In the problem that we're going to be facing, we have some data files. I'm going to break out what those data files are and what is inside them so you get a sense of what you should be looking for. So in this first file, we're looking at maillogs.json, and right here at the top, you can get a sense of the type of data that's in it. This is one record from that file, and it says that the event time was Monday, June 29th at 8 a.m., and the sender was Eponine Thénardier. The reply to was also Eponine, and the recipient was Gilly Normand, also with Thénardier Hospitality. There's a file name that looks incredibly long, email underscore 8EA, so on and so forth. A subject and a result. So first off, what are the columns that we need? Apparently in this table, we have an event time, sender, reply to, recipient, file name, subject, and result. Event time is self-explanatory. The sender should be self-explanatory, and the sender and the reply to are the same thing. So Eponine Thenardier, whoever he or she is at Thenardier Hospitality, was the sender, and it is the person that if you hit reply to on the email that the reply will go back to. And the recipient was Gilly Normand, which seems to be somebody at the same company. Their subject was quick question. And we do not have the body of the email in the log, so I'm thinking we're going to have to check this file name to get if you want to see the body of the email. The body of the email is probably in the file with that name. The reply to we've talked about, and we talked about what the file name means, and finally it says result accepted. I don't know what that means, but I know that this file was accepted. I'm thinking off the top of my head, maybe it was whether the person opened the email, but we will see. The next file we're going to look at is the emails folder. It is email 8EA91F6, so on and so forth. The file name referenced in the previous slide. And when we look at the file, we see a lot of the same information. It was Eponine Thenardier, it was Gilly Normand, it was Monday, June 29th, 8 a.m. The subject was quick question. However, we now have more information. We have the body of the email, and there seems to be a link in the body of the email. So all of the data in this email matches the data from the row that has this file name. So that seems to be the connection between the two. The next file is employees.json. As we look through this file, I find this name of the same person, Eponine Thenardier. She is one of the employees of the firm. Her email address is eponinethenardier@thenardierhospitality.com. So that matches. And we have her user agent, Mozilla 5.0, et cetera, et cetera. Whatever it is, it seems like it refers to a mobile device since I see Android 8.1.0 mentioned in there, and mobile Safari 537.36. But either way, whether it's a tablet or a phone, this seems to talk about the technology that this particular employee's device uses. Furthermore, the IP of the device is 192.168.84.3. So it seems that Eponine Thenardier has an IP address associated with them. So as I look for things in the future, I would look for that IP address to represent her. If I see that IP address, I would think that it means Eponine, because if they were using DHCP, they wouldn't show her IP address in her employee file. It suggests that it's her permanent or static IP address. And when you see a user agent, you remember what we mentioned before, and you know what a user agent means. As I said, it's possible that someone else has a device like this one with the same type of signature to the browsing that it does. However, it is also possible and probably likely that there's not. So at the very least, if we've seen the same exact user agent being used in our internet traffic, we might want to check to see if it was Eponine that did it. Now, there's a file called outbound proxy traffic.txt. It seems to suggest that the inbound traffic and the outbound traffic are in different files. And when I looked into this file, it didn't have headers. So I had to grab a row, and I'll need to figure out what the columns are supposed to be from context. I broke them up into separate lines. The first one, 2020-06-29, 8/19/15, seems to be a date and a time. So this, we can feel comfortable that this first one is daytime. Next, we see just the word get in all uppercase letters, so that looks like a web request verb. The third one, 192.168.84.3, not only seems to be an IP address, it's the same IP address we saw on the last slide, Eponine Thénaudier's IP address. So this seems to be outbound traffic that was done by Eponine. And apparently she went to the site gray.biz/home, and I see that there's a different column for the full URL than there is for just the path. So that seems to be how they're breaking up the URL in the outbound proxy traffic file. Next, there's something marked that we don't have any idea what it is yet because it's just marked as none, and it's hard to figure out what that is. And finally, this is a user agent on that last bit, and when you check it, it'll be the same user agent used by Eponine. And of course, the IP address also matches, so that this was outbound traffic that Eponine did using her tablet or phone or whatever the device is. And next, we have our inbound proxy traffic file. So this seems to be internet traffic that is incoming. It also has no column names, but the columns are slightly different. Now, the first one is clearly a date time, and the following one is an IP address. But 43.244.185.104, if you look through the people file, doesn't match any of the IP addresses of the people in our company. So that seems to be an external IP address. And then it's followed by what looks like another web request verb. And then in this file, for whatever reason, the URL is organized differently. There's one column for just the domain name and a separate column for the path. And you would have to put both of those things together to get a working URL. But that seems to be the way that it's recorded in the inbound proxy traffic.txt file. And then finally, we have what seems to be a user agent, but different than any of the user agents that I currently see for people working in the company. And in fact, whoever this was using Windows 98, it seems, and Opera, which is an alternative browser with an absolutely ancient machine. So it's some stranger from the outside that was doing it. And now that I've examined those and I have a sense of my different data tables, I realized that given that I have data in my emails directory, my mail logs.json file, my employees.json file, my outbound proxy traffic.txt file, and my inbound proxy traffic.txt file, I might want to see how the data between these different files have relationships. So first, let's take a look at emails in the mail logs.json file. If I look at the fields in these different files, I can see from and sender should be the same. I can see that sent and event time are similar, that to and recipient should be the same, that subject clearly matches, and that body is in the file, but it isn't in the log. So body can only be found in the email, in the file that the email is stored in. Additionally, I can see that reply to, file name, and result are things that I need to pay attention to. Reply to because it might or might not match the sender. File name because it's where I will find the name of the emails in the emails folder, and result because it is a standout and I don't necessarily know what that means, but I'm going to need to figure it out before I'm done. Next, I want to see how the maillogs.json file matches up with the employees.json file. So I pulled out the fields that are identified in both, and it looks like sender, reply to, and recipient all might match the email address in the employees.json file, and that seems to be the only place where they match up. Another combination that I would want to take a look at would be employees.json and outbound proxy traffic.txt. So for one thing, the user agent in employees.json and outbound proxy traffic.net should match. There should be matches there, and if they aren't, then it's somebody that isn't an employee that's using our network. Secondly, the IP address should match the outgoing IP address that is in the outbound proxy traffic.txt file. but you should look for the IP address when possible to do matches. And finally, I think we covered all the things that we need to do or that we need to look at. So now we need to look at how are we going to start digging into this. In order to dig into it, we will be using Linux commands: ls, cat, cd, and grep. ls is the command that allows you to list all the files in the current directory, and you use it just by typing in ls. The cat command allows you to display the contents of a file, and you would use it by saying cat plus the file name of the file that you want to see the contents of. And then the change command, the change directory command, or cd, is used to change to a different directory, and you would use it by typing in cd space the directory name that you wish to switch to. And finally, the grep command. It stands for Global Regular Expression Print. It allows the user to search inside of a file or files for a matching term, the combination for a matching term. And it could be used by saying grep space the text that you're searching for space the name of the file. And the combination of these commands will allow a user to analyze log files. Now, the situation that we're trying to solve is with the Nadia Hospitality. And there's several questions that we need to get to the bottom of. Several users have reported suspicious emails from resettwitter@hotmail.com. How many emails did this user send to my organization or my client's organization? Some of these emails might have been blocked by the spam filters. How many were actually delivered to users? What domains were used in the links contained in these suspicious emails? Which users clicked on those links, and which IP addresses were associated with these links? And we're going to dig into that by going directly to the command line. Okay. If I type in ls, I can see all the files that we just talked about available in my directory. Emails, employee.json, inbound proxy traffic, and so on and so forth. And I want to see how many emails that this person sent to our organization. So what I want is in mail logs.json. So if I type in cat mail logs.json, I get a lot of emails, and it's garish, and I don't want to go through it manually and count them one by one. So what I can do instead is use grep and search for the email address that I'm supposed to be searching for inside of maillogs.json, and it'll give me back what looks like 3 records. And I'm going to copy and paste this into my notepad so I can keep track of it. So the answer to the first question, how many emails did this person send to my organization? It was 3. And the second question is, some of these emails were blocked by spam filters. How many emails from this sender were delivered to users? And then we get back to this result column that I didn't know what it meant, but I have results accepted, and result blocked. Now, if it was whether someone opened or did not open the email, I would imagine it would say accepted or rejected. But the fact that it says accepted or blocked, I'm going to take this to mean whether or not the spam filter stopped people from receiving it or not. So apparently, the answer to the question, how many emails from this sender were delivered to users, the answer is 2. Now, what domains were used in the links contained in these suspicious emails? I need to go into the bodies of the email, so I need these file names. So I'm going to copy this file name, change directory to the emails directory, and say cat. And if I say ls, you can see I have a bunch of just files with really, really long names. So I can say cat and then paste the name of the file name of that first email. And as I look here, I can see that everything matches, except the body of the email was a FedEx delivery was not able to reach you. Please click the link below to reschedule delivery. And it's servicetwitteruser.co, which seems suspicious. So let me take that, paste that into my notes, and move on to the next one. So I'm going to grab this next file name, copy it, say cat, and paste it. And I will get businesspaymentfinancial.co. So I'm going to copy and paste this. And the third one was rejected, and there's no file name for me to go to, so I wouldn't be able to pull it up if I wanted to. So I have the domains used in the different links, which users click these links. And the only way that I can figure that would be possible to figure out would be using the outbound proxy traffic file. So if I take a look at that, it's a massive amount of data, but it shows the links that people went to. So maybe what I'm looking for is a link that's over here that's also in my outbound proxy traffic file. So let me grab this first file, copy it, and do a search. So grep that file, that link inside the outbound proxy traffic.txt file. And there was no traffic found. Let me clear my screen to make it clear what I found. Nothing. Okay. So let me look at the next one. Grep. I'm going to grab this next link, copy it, paste, and also look in the outbound proxy traffic.txt file, and I get nothing, which seems a little suspicious. And just to be on the safe side, I'm going to look to see if anybody else in the company might have looked at these links, even if it wasn't the people that I'm checking for. So I'm going to grep just the domain with whatever path that it uses, and I'm also going to use the outbound proxy traffic file. And I got a hit. And the hit that I got was for someone with the IP address 192.168.84.4. And if I wanted to find out who that was, I would go to the employees.json file. So I would say grep. Nope, that's wrong. I would say grep, and then I would need to type in the IP address 192.168.84.4. And I'm going to look for that in the employees.json file. And it doesn't really help me. And it's because each field is on a different row, but the file isn't that long. So I'm looking for 84.4, and that's a Zelma Thenardier, who is the person that first email was sent to. And so the question might be, why didn't we get a hit? So let me clear. And what I did the first time is I searched for www.servicetwitteruser.co with everything. And then I just look for servicetwitteruser.co. And they look the same. So maybe I had some type of control character in there or something. And these types of mistakes do happen. Or maybe it was the line return. I'm not sure. But it seems like if I searched for this, copy, if I search for this inside outboundproxytraffic.net, I do not get a hit. And the reason for that is that we didn't enclose it in quotes. I made a mistake. So Googling on grep, you found that grep doesn't just use things exactly. It also uses wildcard characters and other things. It's looking for pattern. So if instead I had said grep with quotation marks, so I'm going to put double quotes here and then double quotes at the end, it would have found the hit, which is unfortunate. So I made a mistake. I didn't use the word the grep command carefully, and you need to be certain to do so yourself. So this is 192.168.84.4, which we already checked, and it was a Zelma Thenardier. And it would help if I spelled it right. And that means I also need to go back and double check the other one. So I looked for business payment financial. So let me put double quotes around that as well, so grep doesn't get confused about whether I'm literally asking for it with these apostrophes and slashes or if I'm looking for a pattern, and hit enter. And boom, I have another hit. And this one was 192.168.84.8 and 192.168.84.2. So I have two people that bit this apple. And the reason for that might be that it was forwarded from one person to another. So 84.8, and the second one was 84.2. And so I need to if I look in employees.json, I can see, of course, that 84.8 is Jean Prouvaire. And 84.2 is Fantine Wild. So in answer to that question, which users clicked on these links, it was Azelma, Jean, and Fantine. Now, finally, the final question was which IP addresses were associated with these links. And when I looked in the outbound traffic file, we have the originating IP address, but then we also have this address, 230.145.84.113. So it seems that Business Payment Financial has an IP address associated with it. And it also seems that Service Twitter User 145.217.142.119 has an IP address associated with it. So those are the IP addresses associated with those links. And just to be on the safe side, I want to see if there are any other links that point to those IP addresses that the staff that I'm worried about have been browsing to. So I would do the same thing. I would say grep. I would put in the IP address, and then I would look at my outbound proxy traffic.txt file, and I just get that same one with 84.4, fine. And I would also look for this IP address in my outbound proxy traffic.txt file, and I get those same two again with 84.8 and 84.2, which are Jean and Fantine. And just for giggles, let's take a look at our inbound traffic. Are we getting any inbound traffic from those IP addresses? So I would say grep that IP address in my inbound proxy traffic.txt file. Nothing. I would say grep this other IP address and look at my inbound proxy traffic.txt file, and I have nothing. So what I found out is that more people than received the email actually clicked on the link. So we need to talk about phishing emails. We need to talk about forwarding emails. We need to have training at our staff. We figured out how far it's gone. We figured out which machines that we need to check. It would be the ones that belong to a Zelma, a Jean Prouvaire, and Fantine. And we did all of this using digital forensics. We figured out what happened, and we figured out the extent of our exposure. Hopefully this will be helpful to you. Please take the time to go back over this information before you begin working on your test data folder. Thank you.